Okay, so let's continue. 41 function. Function of several variables. So last time, we defined a function f from D is in R2 to R. So we call this is function of two variables, and f, x, y, we write it in this format, and x, y are called independent variables, and z is called dependent variable. And also we define the domain. Domain is domain of f is x, y in D, and fx, y is legal, like that. So I talk about the range, but I think the range for the range of the function is hard. So I didn't give you an example. I don't think we will test you that part. It's very important, but now it's hard. We will talk about this, the range later, after we study more tools or techniques. Okay, this is what, of course, I gave you some example last time. So today, we will, wait for a moment. What happened? Today, we will continue to study functions of several variables. So let's continue. So let's first introduce. Let's introduce graph. I think the spelling is right. So let's first look at a 1D case. I think everyone should know this. 1D case, if we have a function from I to R, I is an interval. For example, I is A, B, where I could be R, right? Nobody knows. And then we define the graph of F is the pair f x for all x is in I. How do we think about this? This is the graph of the function, and f is a function. There are two different objects. Okay, so let's draw a picture. For example, if x is x squared, I is negative 2 to 2, right? So the graph, every time, maybe you didn't think it in this way, but when you are draw the picture of the graph, the function, you are drawing the graph, not the function. So for example, we knew this in our high school. This should be like this, right? This is negative 2. This is 2. They are symmetrical about the two y-axis. This is x, is y. You pick any x, you get fx. This is the point. You are drawing the graph. You are not drawing a function. I think that's a language, right? I know you knew this before. I just want to emphasize the concept. This is a function. This is a graph. Okay, automatically. So I'll stop the video because I don't hope you know, because sometimes the internet is bad. I just stop the video. You don't have to look at me. Okay. Stop the video. So, and then for our case today, 2D case. Okay, one more. What I want to emphasize that you put this in R2, right? You can never draw a function in R1, right? You know, because in R1 you only have a 9. How do we draw it? Everything is in 1 9. Okay. And then let's look at a 2D case. Now we have a function f from D to R. Now D is in R2, right? We can say X, Y is in RT. So further, okay, wait. So we define the graph of f is x, y, and f, x, y for 1D case, because there is only one independent variable. So you only have x. Now you have 2 independent variables. You just put the 2 independent variables together and add the value together, right? And then you get a triple, right? It's a coordinate in R3 for all x, y is in D, right? You get the graph of the function, or you say this is just a definition. Okay, just emphasize this is a definition for our today. And then how do we draw it? The problem is that, okay, I give you a function. Can you draw the graph of the function? That's kind of the problems. Okay, you can imagine you pick any x, y. This is in R2, right? And then you put your R2 in the 3D coordinate. Right? You pick any x, y is here. You get a value like f, x, y. You know, when x, y is x, y changes in D, you get a lot of value f, x, y, and then you draw a picture like this. Okay, you get a graph. Under this surface is the domain D. Anyway, this is so abstract for you. Let me show you examples. Let me study this by examples. Okay. So let's first try a very simple one. So now we have a function f, x, y, which is 3 minus 6 minus 3x minus 2y, right? Draw the graph. Or sometimes people say, okay, what's a picture of fx, y? It means that, you know, what's the graph of this function fx, y? So how do we draw it? So, you know, there are many techniques. You can say, why not, okay, pick any x, y, and we plug in a lot of numbers x, y, and find all the z. Okay, try to figure out. No, I think that could be very hard. You know, sometimes you have to study more techniques. So let's think about it in another way. So we let z is 3 minus 6 minus 3x minus 2y. We change it to 3x plus 2y plus z. What's this? We already knew this is a plane, right? And then how do we draw a plane? Okay. So we know it's a plane, right? So let's first draw the coordinate. This is x, this is y, this is z. No, sorry. This is z. Okay. So let's find the intercept with the axis. Okay. We can pretend yz is 0. when yz is 0, r0, sorry, yz are 0, x should be 2, right? And then let xz be 0. We get a y is 3, right? When x, y are 0, z is 6. Let's say 6. And then we connect them. We get a triangle, right? This triangle is lying the plane we are trying describing, right? You may say, why not draw the whole picture? How do you draw the whole picture for a plane? You know, you can just imagine, because infinity, I just show this, and then you can imagine, okay, you extend this part, this direction, you get the whole plane. Okay, I hope it is clear for you. So by this, you can get the plane, because the domain is R, right? Or if I ask your domain, the graph only on this part, okay, that's the graph of the function, but the domain is R. Okay. Oh, sorry, it's R2. If I made a mistake, please point it out. So this is a very simple example. In general, the question we're asking, okay, sketch the graph of some function. I don't know which function. You have to do some homework and then try to figure out the example, the common example. Don't worry about the very complicated functions. Even I don't know how to compute it. Just very hard. So let me save the. What happened? Okay, I saved it. So this is our first example, and then let's look at example 2. Oh, our second example. This is about a sketch the graph of gxy, which is 9 minus x squared minus y squared. So first, if you look at the function gxy is square root of 9 minus x squared minus y squared, you know x squared minus y squared should be, sorry, plus, no, minus. Okay, the same. Plus is less than 9, right? Because under the square root, this number should be non-negative, right? So we know this is the domain. So we get the domain. So means that x, y can be only chosen in a disk centered at a range with the radius r equals to 3. Okay. And then let's continue. So let z is square root of 9 minus x squared minus y squared, and then we squared on both sides. We get z squared is 9 minus x squared minus y squared. So let's change it to other format. Okay, we get z squared. Just move x squared y squared to the left hand side from the right hand side. Okay, we get line. So what's this? Right, it's known. This is it's a sphere with center 0, 0, and radius is 3. But you have to be careful here because z is greater than 0. We know it's a sphere, but the third component z is positive. Okay, so So let's draw the picture. This is X. This is X. This is Y. This is Z. So when you are drawing picture, it should be like this. Right. So this is, anyway, seems bad. Anyway, that's fine. So let's do one more. So a sphere or the hemisphere or the upper sphere with center 0, 0, r equals to 3. Okay, this is our second example. So you have, that's finally, I just write a remark. You have to know how to sketch the graph for basic functions. This some easy function like that. Okay. So I will only show you two because I think in the homeworks they have some problem like this. Okay, you just go there, find and try to practice your brain. So let's continue. So after we talk about the graph, and then we are going to talk about the level set. So level set. This is very important for us. So first, so if we have a function f from D in R2 to real number R, we can define the level set here. K is a number which is X, Y is in D, and F, X, Y is K. So what do you mean by this? So this is, find all X, Y in D such that their value are the same. Okay, that's it's kind of, when you are climbing a mountain, right? So it's kind of, find the position where your distance is 100 feet to the sea level, like that. Okay. Anyway, there are many explanations. Okay. So this is for this case. Okay, let me look at this. This is called the level curve. You may say why you put level curve, because x, y are two independent variables, but here we have a constraint. We have a constraint. In general, in math, if you have a constraint, the independent variable will reduce by one. If we have two constraints, the independent variable will be reduced by 2. I say general, not always like that. Okay, so we can continue, go more. Even I didn't talk about it a lot. For example, we can, okay, I will introduce here. Okay, so we have a function f from D in R3. So it's kind of a domain, a subset in R3 to R. I will explain more because the book, the textbook, he just talk about 2, and then he say, okay, we'll do the same for R3. But when I was studying this part, our textbook just say, okay, let's talk about any variables. We may talk about the examples for in R2 or R3, but the theorem is about any variables. I prefer that one, but here I have to follow this textbook. Okay, and then like what we did, f, x, y. Now we have three variables like f, y, z, like that. Nothing changed, just the same, add one more. If you know this, okay, we have f, x, y, z, w, right? 4 variables, 6 variables, 10 variables, it's the same, nothing changed. Okay, this is called a function with of 3 variables. Okay, we can, by the same method, we can define x, y, z in d, f, x, y, z equals to k. Nothing new, just add 1. Okay, this is called level surface. So curved surface, because we here, why we create a surface, x, y, z, there are 3 independent variables. We have a constraint, and then the independent variable reduced by 1. So it's a surface. Maybe I rather remark there is a common like the intuition. In general, 1D, we create a curve. Line is just a special case, straight. Straight curve is the line, right? Well, maybe you may say, okay, we create a straight line. Anyways, that's just English. There is a general, this kind of stuff is a curve. Straight line is just a special example, And for 2D, what's 2D? In general, a surface, we call it a 2D. Okay, or 2 variables. If we have 2 independent variables, we call it a 2D surface. Okay, or in 3D, we call it a, just no name, it's just something in R3, right? I cannot go furthermore because if I go furthermore, there are too many mathematical notation. I just, when you know the basic surface in the future, the people say, okay, that's a surface. It means that, okay, it's 2 dimension, like that. Oh, it's a curve, or it's a line. It means that it's 1 variable. It's because if you look at this is kind of geometrical concept, because the curve surface is geometrical concept. But when you are talking about the dimension 1D, 2D, 3D, that's not geometry, that's algebra. Okay, it's kind of, you have to connect the 2 concepts together. I think in general, in structure, a lot of emphasis there. As far the reason that I emphasize that because I studied the geometry, The reason is that I think this is very important for us to understand this, the geometry and the word. So let's look at examples. Okay. Example. So now we consider a function f, x, y. So this function is x plus 2y minus 3. This function is from R2 to R. Now let's consider LK. LK is x, y in R2 and f, x, y is k, right? And then, so let's plug in this function. We get x plus 2y minus 3 is k. And then we get x plus 2y is k minus 3. So what's this? Well, what's it? Right? So let's draw a picture. So for different k, this is a different line in R3, right? So now, so you may say, what are you doing? So I'm help you to understand the levels. You can say if k is 3, if k is 3, no, yeah, if k is 3, you get the level set for k equals to 3. And for example, when k is 1, no, k is 4, and then this is another level set. And when k is 2, oh, for this case, no, k is 2. We continue this for different case. You get a different level set, but for this time, it's very simple because all the level sets are just lines and they are parallel to each other. Okay, that's the level set for this example. But you may say, okay, it's so easy, but for someone it's quite hard. Anyway, so let's continue to another example, a new example. For this one, I'll give you more information. So now we have fxy, which is x squared plus y squared, right? And then let's consider LK, x squared plus y squared equals 2k. And then you can say we have 3 cases. First, as k is greater than 0, xy plus y squared is, okay, right? This is a circle with radius r is square root of k, right? If k is greater than 0, the level set, I'm not talking about the graph, okay? You have to distinguish the concept. I know sometimes it's quite, easy to miss, you mixed everything together and then you made a mistake. That's a common mistake. So this is the third with radius r. You can say if k gets bigger and bigger, your circle gets bigger and bigger. Okay, this is case 1 and case 2. This, okay, let's first finish it. As k equal to 0, we get xy plus y squared is 0. You just get a point. 3 at k less than 0, xz plus y 0. Implicit, right? Because low x and y satisfy this equality, okay. Here I want to say more. First one is that, like I said, in general, I said the level set is a curve, right? For this case, it's a curve, right? Nothing surprise. You can say, if k is 0, is it a curve? No, it's a point. That's why I said in general, it's a curve. The dimension is decreased by 1 or is reduced by 1. But there are some special cases. Just there is no general like a, rule say, okay, what's the geometry of the level set? I know some regard, but we cannot describe everything now. You just care about you just think, keep in mind that we only care about the good case in our class. You can say the third one, this is empty, nothing, right? This is what we care about. We will not like say, okay, let's understand the level set. For the bad case, we only care about the good case. The reason is that it's too hard for you guys. Okay, you just like what I said, get the feeling. Okay, if we have a constraint, if we have one constraint, the independent variable is reduced by 1. If we have 2 constraints, in general, the independent variable are reduced by 2. Okay, that's what I want to say. Okay, you look at this example, it tells what I want to emphasize. Reduced by 1, you can say this is reduced by 2, right? Point is 1, is 0 dimension. Anyway, this is just nothing. Okay, like what I said, finally, I will write a remark. So I will write a remark. Also, the remark is also from the book. It's kind of, I more emphasis about the function with 2 variables, right? But everything can be generalized to many variables. For example, for this is fx, y. So 3 variables. Even I talked about a little bit before, but you have to do it by yourself. F, y, z. In 4 variables. In general, if there are many variables, for example, 100 variables, we don't have so many alpha, beta. In general, people will say, okay, let's write fx1, fx2, fx3, fx4, and n variables. I think some of you are from economy department. You know, in your like the microeconomic class, I think you deal with many variables, right? This is not new things, right? Okay, fx1, fx2, fx3, fxn, right? Just for example, why not give an example? Okay, for example, fxy is x plus y plus x squared, like this. fxy z x plus y. Even you write 3 variables, there can be only 2 variables, or you just say square, like you don't, if even there is no y, it's okay. Okay, fx1, x2, x3, x4. This can be x1 plus any number, you know, like this. Anyway, go more further and further. So we will not emphasize this part, but you have to know this by yourself. So after this course, you know, nobody will teach you like the 100 variables problems. If you meet with it in your field, you have to deal with it by yourself. To be honest, this part is very important in statistics. It's kind of many variables because, you know, math is not that important in your life, but statistics is very important if you find a job in industry. Okay. So I studied math, but you know, just it's very hard to find a job. Okay. Example. So now let's look at f, x, y, z. Do a little bit of triple variable because finally we will use this a lot. Z minus y plus x, y sine in z. So the problem is that find the domain. Okay. Okay, one thing I want to emphasize, because our class, we have like 9 students, but every time we only have 7 people come here. So what I want to say that you have to take the midterm exam and the quiz. Because we only have 6, I only get 6 students the quiz. If you didn't take the quiz and the midterm exam, I don't think you can pass this course unless you did a very good in your final exam. Okay, this is what I want to emphasize. Okay, you have to take the quiz and the midterm exam. Otherwise, it's hard to pass this course. Okay, that's some I want to add. So let's find the domain. The first one, if you look at the ln z minus y, we will get the constraint is this is greater than 0. So means that z is greater than y. And then if you look at the x, y sine in z, no constraint on x, y, z, right? Means that this is the only constraint. So now sketch the domain. Sketch this. Okay, this is the domain. Okay, draw a picture for this one. So you can say, or you can see there is no y and no x. So means that x can be any number. Like what I said before, for this kind of this type of problems, you just pick any x and draw a picture. So let's first draw the picture in the YZ plane. So if you look at the YZ plane, so this is Y, this is Z, and then you make Z, this is Z equal to Y. So means that the domain is this part in YZ plane, right? And then for any X, the picture is like this. Okay. When you are thinking about this, you can say we can draw a picture. Let YZ is the floor. X is pointing to the cell, right? It's kind of point upward. It's okay. You can do it like this. And then you just move this part upward or downward, get the picture. Okay, let us do in the traditional one. Maybe you feel it's hard, but for me, it's the same. Okay, let's first, this is X. Okay, sorry. This is X. This is Y. No. So because in case the vision, this is X. This is Y. This is Z. Okay, let's erasing. Go down. So let's, Z is greater than Y. It's the same. You just pretend, the left, how to say, the left wall is the XY plane. The left wall, okay, is our YZ plane. And then you try to draw a picture. Let me change the color. It's quite, it's quite hard to draw a picture in 3 dimensions. Right? Z is greater than 0, right? So it's we can, Z is greater than 0, means that you can say the YZ plane, above this line, we continue to, for every X, we draw a line like this, right? So the domain is above. Oh, let me change the color. It is above this plane. Oh, hope so. I hope it's clear for you. This is the plane above this plane. Okay. Hope so. I hope it's clear for you. Okay. Anyway, it's quite hard to draw a picture. Okay. So this is about the function of 3 variables. One more example. What time is it? Oh, sorry. Because my clock in my home is Easter time and it scared me. Okay. One more example. So let's look at f, x, y, z. This is x squared plus y squared plus z squared. Okay, let us consider the level set z, which is x squared plus y squared plus z squared is k. So, and then like what we did, like look at this example, left hand side. Okay. Okay, x squared plus y squared. For this case, we consider, okay, let me, because I only finished it in this page. Okay, so we have three cases. Case one, k is greater than 0, we can assume k is r squared. And then x squared plus y squared plus z squared is r squared. By this, we know it's a sphere. We at the center 0, 0, 0, and radius r, right? So this is just a sphere. Right, a sphere. A sphere. Okay, and then as k equal to 0, xy squared plus y squared plus z squared is 0, just 1 point, right? The origin. The origin. Not orange, okay. Okay, anyway, that's fine. Okay, 3, as k is less than 0, it's empty. Like what I said, you can say for this case, the independent variable is reduced by 1. It's a 2-dimensional surface. Okay, it's a sphere. This example is very important. Okay, you have to memorize this for our future. Of course, for our course, okay. Not for your, field study. So I think all this is about the function what I want to talk for our first hour, right? So let me stop recording and continue the new stuff. Stop recording.